Hey kids, this is Mr. Cozy, and this is video number 4, which is about radicals. We're going to review the definition of radicals, talk about how to take radicals of different kinds on numbers and variables, and then if time allows, begin talking about simplifying radicals. So let's get started. Whenever you raise something to a power, like x to the 5th, there are two ways to think about undoing this operation. And the difference is what's important. What do you want to preserve? In this case, I have no idea what x is. I might want to know that. So I would take a radical, because radicals preserve the base of the exponent. They get rid of the exponent and preserve the base. On the other hand, if I know what the base is but have no idea what the exponent is, I would use a logarithm, because logarithms preserve the exponent. I misspelled preserve. Let's try that again. Preserve. There we go. Close enough. Preserve the exponent. Okay? We'll talk about logs later in the year. Today we are talking about radicals. Now, there's a radical for every kind of exponent. The type of radical that you are probably most familiar with is the square root. There's also a cube root, fourth root, fifth root, and so on. This radical here, this exponent here, I would undo with a fifth root, because it's to the 5th power. Okay, so let's explore this. If we are taking square roots, the question that you want to ask yourself is, what number squared? What number times itself equals the radicand, which is the number under the radical? That's called the radicand. So what times itself is 16? That is 4. Okay? How about what times itself is 25? That would be 5. Okay? Now, that's square roots. What about cube roots? What times itself times itself? So what number cubed equals 8? 8 happens to be 2 times 2 times 2. So the cube root of 8 would be 2. How about a fourth root? Now, as these get larger, it gets a little bit harder to think of the correct number. But 81 is 9 times 9. So if this were a square root, I would answer this with a 9. However, each of these 9s is 3 times 3. So 81 is actually 3 multiplied with itself 4 times. So the fourth root of 81 is 3. Take a stab at the fifth root of 32. Ask yourself, what number multiplied with itself 5 times equals 32? And the answer is 2. Okay, so for each of these, I take what type of radical it is, and I ask myself, what number do I raise to this power to get my radicand? Okay, so if it's a 6th root, I would ask myself what number raised to the sixth power is 72. Now, spoiler alert, most of the time, these don't work out. For most numbers, there isn't a single neat little integer number that you can use to get your answer. A lot of the times, these are irrational numbers. And so if unless we wanted to write out some crazy long decimal, we would just leave it in this form and say that this is already simplified. Okay. Now, this is all numbers. What about variables? Well, if it's a square root, let's start with square roots. What I do is I divide every exponent with the type of radical that it is. So this is a square root. So I divide the 4, this, and this with 2. 4 divided with 2 is 2. That gives me x squared outside of the radical. 2 divided with 2 is 1, so I have y to the first outside of the radical, and 2 times 2 it is 4, so that's my coefficient. Okay? So, and that I do that for every type of radical. So if it's a cube root of 64, x to the 6th, y to the 5th, I would divide every exponent with a 3. And whatever result I got, I would write outside of the radical. So x to the 6th, I divide 6 with 3, and I get x squared outside of the radical. 64 is 4 times 4 times 4. So that's my coefficient. Now, with the y here, I have a problem because I can't evenly divide a 3 into 5. So what do? I take the quotient of that division of 5 divided with 3 is 1, remainder 2. Okay? The quotient I put outside of the radical, and the remainder I leave inside of the radical. Okay, so it looks like that. 4x to the 2nd y times the cube root of y squared. Okay, let's try this again with a square root. Let's try square root of 4x to the 5th y squared. So divide each of these exponents with 2 because it's a square root. The quotient goes outside, remainder stays inside. So x to the 5th, 5 divided with 2 is 2, remainder 1. So I put x to the 2nd out in front. That's my quotient. My remainder, x, stays under the radical. Now y to the 2nd, 2 divided with 2 is 1, so a single y comes out. And now don't get confused, because with the coefficients I play the same game I was playing over here. What times itself is 4, and the answer is 2. So this is 2x to the 2nd y times square root of x. Okay, let's do one more, and then we will call it a day. Do the 4th root of 16x to the 4th y to the 9th. Okay, so what times itself 4 times is 16? That's 2. Divide x to the 4th, divide the 4 with the type of radical it is, and I get an x to the 1st outside. Do the same thing with the 9. My quotient is 2, so that's y squared. My remainder remains under the radical 9. Okay? So there we go. Now we're going to apply this same logic of dividing exponents when we simplify, but we'll talk about that tomorrow. I am out of time right now, and I think I've thrown enough information at you. So have a great evening, and I'll talk to you later. Bye.